Now we're going to use that formula for arc length of a polar curve to find the length of a couple of different polar functions. This one is called a limacon. R equals 1 plus 3 sine of theta. We are going to find its length. In order to do so, looking at the formula here, we're going to need to know what dr d theta is. Well, we can find that out. Dr d theta is equal to 3 times the cosine of theta. No tricks to that. And so the arc length of the entire limacon is the definite integral from 0 to 2 pi, because if we start here when theta is 0 and go all the way around, theta is pi over 2, theta is pi, theta is 3 pi over 2, but with a negative radius. In here, the radius is positive again, and now theta is 2 pi. So it takes us that long to get all the way around. So we're going to use the definite integral from 0 to 2 pi of dr d theta squared, 9 cosine squared theta, plus r squared d theta. So the r squared, I'm just going to write it as 1 plus 3 sine of theta squared. I certainly could FOIL that out. But it doesn't really add anything right now. Although, yeah, it doesn't really add anything right now. So what we're going to do is use Desmos to find that definite integral. The definite integral from 0 to 2 pi of the square root of 9 times the cosine squared of theta plus, make sure you have your parentheses here, for 1 plus 3 sine of theta squared. All of that in respect to theta, and it's 19.379. That wasn't so hard. But now we're going to check for reasonability. So a lot of times you're asked this, like, does that answer make sense? So one way we can check for reasonability is compare that limacon to two circles, because as the particle moves around that curve, it basically does a giant circle and then a smaller circle. Not exactly, but pretty close. And those two circles, one of them has a radius of 2, because you can see the diameter would be from here to here. So one of them has a radius of 2. And the smaller one has a radius of 1. So let's see, what is the circumference of two circles? One has a radius of 1, and the circumference of that would be 2 pi. And the other has a radius of 2, so the circumference of that would be 2 pi times 2, or 4 pi. And that equals 6 pi. And I don't expect you to know 6 pi off the top of your head, except pi is a little bit more than 3. So 6 pi is going to be a little bit more than 18. So 19.379. That makes sense. That's all that you're being asked for if you're told to check for reasonability. Compare it to some simple shape and see if the answer makes sense. The next example, which uses, by the way, the exact same polar function, is a tiny bit tricky, because all I'm asking you for in this one is the length of the inner loop of that limacon from here around. Everything about the formula is the same, except the limits of integration. So I'm still going to use the same dr d theta, which is still 3 times the cosine of theta. And I'm still going to use the same integral, but we need to figure out the limits of integration. So here's what we need to think about. When theta equals 0, the radius is equal to 1 plus 3 times the sine of 0, which is 0. So 1 plus 0 is 1. So we start at the point when the theta is 0, meaning when the angle is pointing horizontally forward like that. We're at the point 1, 0, meaning the radius is 1, the angle is 0. And we move as theta gets bigger, we move around the curve here. So what we need to figure out is when does this curve to start the inner loop, when does the radius hit 0 again? So the question is, when does 1 plus 3 sine of theta equal 0? Because at first the radius is positive, and it's positive, 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 but eventually that radius starts being really small, really small, really small, and then eventually negative. And we end up with a negative radius somewhere in the third quadrant. So that's why it's in the third quadrant when the angle is pointing this way, but because the radius is negative, the curve is back there. So what we need to do is figure out when that happens. So again, we are looking for when does 1 plus 3 sine of theta equal 0? And we're going to see this one's irrational. If we get sine of theta by itself, we were looking for when is sine of theta equal to negative 1 over 3. And to be honest, you're not expected to know that off the top of your head. So this is where we can turn to Desmos and say, all right, we're looking at the graph of 1 plus 3 sine theta. Call it x. I want to know when, at what values does that hit 0? So I'm looking for the zeros there. And then another one in the fourth quadrant there. So I know that this graph is not the polar curve, but this does show me when the 1 plus 3 sine theta is going to equal 0, which would be the start and then finish of that inner loop. So our limits of integration will be 3.481 and 5.943. And so our overall arc length will be the definite integral from 3.481 to 5.943 of the square root of dr d theta squared plus 1 plus 3 sine of theta squared, all in respect to theta. And again, we're not doing that one by hand. We would go back to our integral for that. The integral from 3.481 to 5.943 of the square root of 9 cosine squared theta plus 1 plus 3 sine theta squared, all in respect to theta, and that is 5.689. And again, we can check to make sure that that is reasonable by comparing that to the circle, which almost looks like, with a radius of 1, whose circumference would be 2 pi. And yes, this number is a little bit smaller than 2 pi. 2 pi is about 6.28. So we're about 0.6 units off. But if we look at the shape of the circle that I just highlighted, it makes sense that it's the shape of this inner loop is not quite a circle. It's a little bit kind of narrower than a circle, a little bit squishy at the sides here. So it makes a little bit of sense that our radius is a little bit smaller than the circle. So again, just a quick check of the numbers means that my answer of 5.689 is at least believable.